also have all sorts of nodes for scoring and row curve plotting, and the confusion matrix here, row curve here, all of that stuff to evaluate the quality of your models. That's all there, obviously. You can do ensembles. Again, this loop context boosting, right? You build a model, and then you build another model that focuses more on the patterns that your first model had problems with. And you keep doing that, and you get sort of this chain of models that keep focusing on the more and more complicated points. It's exactly what this boosting workflow does. This little boosting loop context does. You can plug in any models, any learner predictor that you want. And we have more, right? There's also bagging, delegating, a couple of other things. And we actually have generic nodes where you can really mess around. You can build your own weird ensemble creation mechanism that just spits out something. You could train on random subsets, whatever you want to do. We have for some of the ensemble methods, for instance, random forest, we of course have a native node that does all of that stuff built within one node. This is, don't worry too much about the details. What I wanted to show here is just the workflow that does model selection, model management, right? Each part here, this upper part, what it does, it reads in with the PMML reader an existing model that maybe you used during today. And then at night, you're going to run this workflow. It's going to evaluate on new data, the data that you saw today, how good is my old model, and it's going to train a couple of new models. Here, decision tree, down here, logistic regression. And then we'll put this all together, and we'll just select automatically the best model that actually works best on today's data. And then we're going to deploy this, we're going to write this out, we're going to use that tomorrow for scoring. So you could run this workflow automatically every night, and it will keep relearning the model. It either keeps using the old model, if that's still the best one, or it's going to replace that with a better model, if it could train a better model, right? The interesting part here is that this is just yet another KNIME table. And the KNIME table that you have here just contains a couple of models that were learned, PMML representation of models, 2 trees, and the general regression model with a little label. So later you can create a report that says, wow, tonight the logistic regression was much better. You get some mean error rate here, and that allows you to just select the best one. It's all part of the KNIME data manipulation stuff. There are, of course, many tools that we build in KNIME, right? All of the, well, we have about 35 learning algorithms, analysis algorithms in there that you sort of keep stumbling across, but there's tons more out there. Our goal is not to reinvent R, right? There's tons other stuff out there that is already doing cool stuff. So we have integrations with Weka, very cool machine learning library, and we have slightly different way of integrating stuff, Python and an R integration. I'll show this in a second how that actually works. So this one just allows you to reach out to all of this. It's automatically generated. We have a node generator that goes into the Weka library and generates for every algorithm that you have in there, automatically generates the node with the corresponding documentation, file, and also the corresponding dialog. How does the Python and the R stuff work, right? That's maybe something that you want to use R. I mean, ggplot2 makes really, really cool plots, right? I mean, we're not going to reinvent all of that stuff. You want to reach out to that one, or just know how to do certain things in Python. Why not reach out to that one? So here's a small example. Let's assume I want to do partially square regression, and I really have no idea how that works. Actually, I don't have an idea how that works. Aaron did that, so if there's any nonsense in there, blame it on Aaron. So we're going to do that, but we want to hide that from the user. We really want to generate this meta node, and that contains all of the magic that's going on. And the magic is here. And the node, what we want is we feed in the data, and we'll generate a nice plot, like over here, and we'll generate the parameters of the partials, the regression coefficients. So this workflow, the one that you see inside the meta node, these are the meta node incoming ports and the outcoming ports. The way you set it up has 1 port in, 2 ports out. And we have a bit of a workflow here that does what we need to do. We'll ignore these nodes for a second. There's something strange going on up here. But there's obviously a Python learner and a Python predictor, so that they seem to be used to actually do the PLS modeling. And then we're using R to generate a view. Not because we have to, but because we can. So I can demo that all in one workflow. Okay, so what does this one look like? The Python learner is actually fairly boring, right? It's a node that allows you to write Python, the piece, and it accepts the data that comes into the node, and it produces something that will be outputted from that node. You can execute the script in here, you can debug it, right? So while you assemble this workflow, you start writing the script, you debug it until you get the right answer and it actually works. And then you close the node and you don't worry about it anymore. Every time you execute this workflow, this Python script will be executed. Okay, so this is easy. And the R stuff looks just the same, right? It's just R. So we're actually doing the same stuff. This is a bit interesting. I mean, of course, the data here arrives as a data frame. In Python, arrives slightly different. So there's a lot of conversions going on underneath the hood, so that it actually, you don't need to worry about those things. And this one is a node that actually produces not data on the output, but it actually produces a view. So you can also look at the plot and mess with this one until you're happy with the plot, and then you close it, and then you have that, and everybody can use it. Okay, so now that works. So the node produces via R the plot, and it produces, using the Python code, it produces the parameters for my regression. Okay, number one. So now it's, of course, a bit annoying. I mean, this does one thing. It would be nice if you could control a few of these parameters, right? How many coefficients do you want? Which column in your data do you actually want to run this on? So that's where these nodes come in. These nodes, the green one, what we call quick form nodes, allow you to define in a way the interface of these nodes. So you can use those to say, those are the parameters that I want people to be able to tweak from the outside. So I want an integer for the number of components from the PLS, and I want a target column. I want the user to select the target column. When it happens, once I have these nodes in here, and I'm actually right-clicking this node, and I choose configure, I get a dialog, and I defined the dialog. So it's now asking me to select the column, and it's going to ask me for these components. So out of the sudden, I can write sophisticated stuff, say, okay, you know, my buddies over there, they don't really know what they're doing, but maybe they know how to control these three parameters. You expose them, that's fine, okay? Fine. Another commercial break. So the analytics platform that I showed you so far really works very nice for expert programmers. They can sort of write cool stuff and deploy it to others, and they don't necessarily need to touch that code if they shouldn't, right? And it's for workflow artists, right? They're amazing, they build cool workflows. But in the end, it's kind of disappointing, but not everybody wants to see KNIME and KNIME workflows, right? You have business users, they get scared if they see a workflow. So you need ways, first of all, to deploy this to casual users, and you also want ways for people to collaborate, right? Somebody writes a piece of a workflow, other people want to reuse that. This wonderful PLS node, wouldn't that be great if that was somewhere central so everybody can actually reach out to what Aaron did? Would be nice. That's what and that's one of the things that we sell, is what we call the KNIME server. And the KNIME server allows you to, well, it allows you to have a shared workflow repository. So each one of the local installations can reach out to that, and they just see all of these things that are residing there. Obviously, it's hooking into your user authentication system, so you have group rights and reading and writing rights, the usual stuff. Has shared data file repository, has this shared meta node repository. So Aaron's PLS node can be uploaded by Aaron. Everybody can use it. When Aaron tomorrow has a much even better idea how to do that, he updates his template, and all the workflows that use that automatically get this update. Okay? It also allows you to do remote execution, scheduled execution, run this night. The one with the model management, you can run that every night, right? Let that automatically be triggered and automatically sends an email to you, says, well, failed, succeeded, attaches a report that says, oh, tonight we picked the decision tree because it was 3% better, whatever. And we also have ways, I mean, that's client access, obviously, from all of the KNIME clients, but you can also deploy these workflows now via web service calls or custom APIs, so you can also embed that into other IT infrastructures. And that's the nice thing, you can also deploy it via our web portal. So you can give people access to these workflows via just a nice web front end. And the quick form nodes here allow you to specify which parameters, what are the controls that I'm going to allow my web portal user to twist, right? So this little example of the PLS regression node on the web portal will look like that, right? You log into the web portal, you got the rights to access this wonderful node. Not a very nice example, but in the end, that's essentially just contains this one and will ask me exactly for the same parameters. The nice thing is here, this is a very, very trivial example, right? But if you have a larger workflow that has a couple of steps, you can literally ask the user for some pieces of information, run a part of the workflow, ask for more information based on what you got there. You can even have case switches where you say, well, if I got these types of answers, then I'm going to ask these questions, otherwise I go down here. So this can actually become very, very complex. It's almost a bit like an interactive analytics engine, right? So you have a front end that sort of adjusts the workflow, what gets executed and how, based on user feedback. Okay, so legacy tools, just 2 slides on that one. We have you always walk in at some point and if there's some analytics infrastructure there's going to be some tool that everybody has been using. It's a command line tool. We want to keep using that because it does amazing stuff. Nobody knows how it works anymore. What we have is 2 different nodes that allow you to call a local tool or call it via SSH. And essentially all we do is, well, this is where the data arrives, this is how we call it, these are the command line parameters, thank you very much. That's sort of the brute force Swiss Army knife for everything that you want to integrate. Writing a Java wrapper about that does a bit more, supports cancellation, reports progress, is really not that much work. So once you start realizing this is actually being used a lot, you may consider doing that. It takes probably a day or something. But that's a very easy way. Within 10 minutes, you're calling whatever you want to call. You could even call SAS on the command line if you wanted. Not sure why you would want, but you could. Tons more, right? We have many, many other nodes for text, for image, for network analytics. We have an integration with Visoni. We have an integration with Cytoscope for network visualizations. We have an integration with the Stanford text processing library. Many, many other things. From the life science front, we can deal with molecules. We can do with next generation sequencing data. There's tons of other integrations that I really don't have time today. Some of these very application specific, customer intelligence, for instance, for uplift trees, very specific thing. That's a contribution from one of our consulting partners. They just wrote the node because they needed it and put it in the community. And then something I'm not going to talk about much, I just hinted at the ability to generate reports. The way we do that is we have an integration with BERT from Actuate, another Eclipse project, so you can switch perspectives and use KNIME to do all of the data massaging and aggregation and table generation and view generation, and then in BERT you just sort of assemble it and make sure it looks pretty. Generates PDF, Word doc, whatever you want to do. Last commercial break, we have partner productivity extensions. We are working with quite a number of consulting partners that are using KNIME for fairly large and complex projects. They don't necessarily want to give away their workflow when they install it and have the customer then copy it or do whatever. And we allow, via our partner productivity extensions, you can actually lock these meta nodes. So the PLS node, if I really don't want people, Aaron doesn't want to share his secrets, right? He locks it up, throws away the key, and that's it, right? Nobody can open that anymore, but it runs. It works, but nobody can look into the insides. Okay, good. A bit of a technical peek under the hood, just I think 5, 6 slides, so you see a bit how it works. You saw this one, 9 workflows. A KNIME workflow is really a chain of nodes that get connected to each other. We have workflow, and literally when you look into the code, there's a workflow.java, and there's a workflow manager.java that actually does that, controls the execution, and also acts as a container. The funny thing is, so these meta nodes that I showed you are just workflows, right? So it's just a nested hierarchy of these workflows, and ultimately at the leaves of this hierarchy you find nodes, right? And the nodes are literally node.java, if you look into the code, encapsulate the functionality of one processing unit for data generation, manipulation, all of the things I've shown you. And they may, if you provide them, they end up having a dialogue. They probably should have a dialogue. Most nodes have a dialogue. And if you want to, you can provide a view or more as well. So they can visualize data, or they can show a decision tree interactively, lots of stuff in there as well. And then we have these ports. And the ports are essentially, after execution, the way to reach the result of those nodes. That's always maintained, store the results, and then the connections are perceived because they aren't really modeled in KNIME, right? They're implicitly there because we know who is connected to who. And they model the information flow, could be data, and this is maybe interesting. So what we do on the data side is we keep it in memory as long as we can. 5 years ago, hidden memory was not good. Out of a sudden, it's good. So whatever you want to hear, we can do it. We do, so it keeps it in memory. But if it gets too large, it caches it out to disk. Okay? So that's KNIME tries to be smart about that. In an expert mode, you can actually overwrite that. So if you really know what you're doing, you can tell KNIME what to do. But I think Bernd did pretty smart. The caching mechanism is very good. And then the database connection, you saw those. The R workspaces, I didn't really talk much about those, but many of these R nodes are actually just transporting workspaces. So you can have a part of an R script that does a bit of data massaging, and then you're branching off in different ways. You're extracting a view, you're extracting a table, you're training a model. So that you can modularize that as well. Or it could be images or documents or other stuff flowing around. This is one of the big differentiators between other tools. Horrible acronym, I know, but what you see is what you run. In our case, underneath the hood, when you model something, every node is really there as a Java class and gets executed as a Java class. Many of the other tools were sort of the graphical front end was invented after the fact. Right? For SAS Enterprise Miner, every now and then you still need to, it translates the visual representation into script. And every now and then you still need to reach out to the script to fine-tune something that you want to do. Right? A lot of the tools underneath the hood are not running what you're visually modeling. In our case, you're really running what you're visually modeling. And each of these nodes, if you write your own node, you're going to have a very, very hard time to kill KNIME, right? Because it's almost sandboxed in itself. This is just a diagram to show how things work we have this workflow manager, a user interface, there's a node interface. All of these are plugged into sort of a node interface, how it behaves to the outside, the dialog, the views, and how it deals with data. And on the data side, we have metadata handling, so it's actually fairly easy using Eclipse extension point, and you can add a new type. So if you have, actually we added already a lot of types, but I'm sure we are still missing some, so it's fairly easy. Some 3.5 dimensional sequences, you add a type for that, and you can add processes for those as well. Data management, same story. For the in-memory handling, we have ways of adding through extension points, also other ways of where your data is stored. So for instance, we have also the ability for next generation sequencing data, for instance. You don't want to pull that into KNIME, and that doesn't fit even on your disk, right? You just want to point to where it is. The same is true for for some of these large picture repositories. And then the execution control, same story, you can plug in other executors. We have a partner company in Redwood City, for instance, they plug in an executor that allows you to run KNIME workflows on Hadoop. So much for that. There's a lot of material on our website for if you're interested in more development details. This is sort of the class node, is really a final class, and you essentially define through a node factory which node model is to be used for that particular node. If it has a view, 1 or 2, and if it has a dialog, you need to sort of extend those classes, and then the rest is handled by KNIME. You don't need to worry much about that. We talked about the states. But it's kind of, that's really the only stuff you in the end need to implement. You need to tell KNIME in the implementation of this node, what does it do when you reset the node? What do you need to throw away? A lot of that memory handling is done by KNIME, but if you do your own little bookkeeping, you need to make sure you're cleaning up after yourself. Configured essentially is a routine that gets called to allow the node to turn from red to yellow, which essentially says, if I gave you that data, could you deal with that, and what would you produce on the output? So it's really sort of propagating the metadata, and then I can configure the next node downstream. And execute actually does it, right? Give me the data, thank you very much, and then there's a lot of execution handling and making sure that whatever you use as intermediate data gets stored somewhere where we can deal with it and clean it up afterwards. And then we have a node extension. There's a KNIME SDK that you can also download, which essentially is an Eclipse Java development environment with all of the KNIME code. And it comes with a node wizard where you just click through and say, I think I have a picture here. You select this one. I can share the slides later. I'm probably a bit late to tell you, sorry. You tell him which package to use, what's the name, what kind of node is it, who wrote it, a bit of description text, and it will automatically generate all of this. It will generate the plugin, it will register it with the appropriate extension point. So when you from here now launch KNIME, the node is there. Doesn't do anything, and all you need to do is fill in, reset, configure, execute. If you want to write a view, that will take a bit longer. Writing nice views that's not something we can do for you. But all of this surroundings, you don't need to worry about all of this extension point mechanisms in Eclipse if you don't want to. Just a comment on node contributions, open source, some of those also commercial. I'm showing that mainly to emphasize that some of those we maintain ourselves. The R and the Python integration is something that we maintain because we believe it's actually of interest for many people. And the Python integration was sponsored by Novartis. Novartis gave us some money and said, we wanted Python integration, please do that, here's money. We're supporting the development. Some are donated by companies. Velvet Cheminformatics are really cool, highly scientific tools. I have no idea what they do. They do something with molecules. Donated by Eli Lilly. A couple of others here as well. Boehringer Ingelheim also is donating some code. Contributions from research institutions. That's a bit of, this is Dresden. They're doing Paladin, really cool text mining. This is OME, a large, from Dublin, an open source image database. These are chemistry stuff. This is image processing stuff. And down here we have some of the tools that get donated by technology partners. Okay, let's talk a bit about use cases briefly, just a few slides. How do people actually use KNIME? Now, the first thing, just to give you a feeling, it gets used everywhere, right? Lots of areas. We started off in pharma, mostly for historical reasons, and I also believe because pharma 10 years ago, they already knew they had a big data problem. They didn't call it big data problem, but they have highly heterogeneous data, lots of it, and they are very good at generating it, and they're very bad at making sense out of it. So it was a perfect niche for us to get started, and that helped us sort of jumpstart a lot of the development that then later also creeped into a lot of these other areas. Those are logos of companies that are actually paying us one way or the other, right? They're sponsoring development, they're buying our server, they're doing something else. Maybe just picking out a few here. Procter & Gamble is interesting. They're using KNIME for retail store analytics, which is kind of funny. That's the Consumer Reports in England. They are training every night using KNIME about 3,000 models for price prediction. So if you go to their website in England, they will actually tell you if you should buy this TV now or if the price will go down further. It's really, really interesting. And they're doing that with 9 models. They're training one model for every product. It's amazing. Really, it's just the number of models that they're training. Activision is very cool. I'm too old for that stuff. My son plays with Activision. Actually, when they called us first, I had to ask what they do. That was very embarrassing. They're using that for in-game analytics in Call of Duty. Really neat. And in 2 weeks in Berlin at our user group meeting, Arthur van Eschen, the head of in-game analytics, is coming. He's going to talk a bit more about how they use KNIME and how they use advanced analytics to find boosters, people who sort of misbehave in these online games. Bosch, you saw that for predictive maintenance, Internet of Things type stuff, lots of others up here. So it's used in many, many different areas. If you want to know a bit more how KNIME can be used, we have an example workflow server. So if you go to the workflow repository, you'll notice this examples here. You right-click, you log in, it's an anonymous login, and it will open up this long list of hundreds of workflows for very, very simple things, cross-validation, 5 nodes, nothing spectacular, to pretty interesting thingies where you do Apache log file analysis, you do something with OpenStreetMaps, or here geolocalization, text mining example workflows. So there's lots of stuff in there to investigate and to learn more about how KNIME can be used. A couple more real life use cases you can find those on our website. You go to the use cases here, and we have some for custom intelligence, and that's a category that keeps growing. So we keep adding something to that. Hey, if you have an interesting use case, send it to us. We'd love to host it here and put your name next to it and your company logo for churn analysis and other stuff. And all of these examples come with a white paper describing what's going on, explaining the workflow, come with the workflow. The workflow automatically comes with data embedded in it. Sometimes it's a subset of data because it's too much to download, but it is a wonderful template to get started. We see that quite often, that people actually start with one of these and say, this is roughly related to what I want to do. I'll use that as a template, and I start adjusting that, and that way get my feet wet with KNIME. 2 examples. Just for energy usage, there was Irish energy meter data, lots of data. You read in time series analysis. You do some clustering on these energy meter time series. You sort of identify clusters of households, 24/7 business, and all of these things. So it's kind of interesting. It's an interesting thing because it's sort of almost like a big data. There's lots of data in that workflow. This one is interesting, forest fire prediction, I think actually California, so this really matters. It's analyzing this. This is nice because it actually creates a report, right? So it summarizes some data, and this is using BERT and OpenStreetMaps to plug in the data into the map and generate an image that then gets embedded into the report via BERT. Good. 3 slides on what we're doing, small peek into the future. What are we working on? Obviously more data into the Blender. If you can't get the data into KNIME, then you have a problem. Sometimes we get approached by companies that say, we have this weird data source, can you help us? Sometimes it's writing a proprietary connector. They are the only one who have that data. But often it just gets yet another data connector into the KNIME distribution. So we have already all of this JSON nodes that allow you to deal with JSON. This is something we are going to present at the user group meeting in 2 weeks. We now have a MongoDB reader, and we're also adding support for CouchDB. So you can also add that to your data mix. Alteryx calls it blending, data blending, as if that's new. We've been doing that for ages. So that's one thing. We keep adding new data sources, reading that in. We are working more on this interactive analytics for I'm still about this masses, I'm not so happy, but anyway, we'll stick with the term for now. The point of this web portal that allows you to sort of step through a workflow, we're starting to make that even more interactive, so it's not just asking for parameters that you can adjust, but we're going to give you visualizations where you can select pieces of data or a slice of histogram and then keep going from that with your workflow. So we're adding a lot more JavaScript functionality to the views, to the view framework, So you can hide not only code, SQL, Python, R, whatever, but you can also hide some of this interactive view complexity that helps, of course, the web portal a lot to deploy interactive advanced analytics to people without having to deal with the KNIME workflow. I still personally think that's a mistake. They should all be using KNIME, but the workflow is beautiful. But anyway, that's another problem. I'm very scared about this analytics for the masses because I think ultimately you will underfit what people know, so you need to be very careful about that. But that's, again, personal opinion. Another thing that's cooking in the labs, we're working on an MLlib integration, so you can not only do what you can sort of express via SQL and push that out to Hadoop, but you can also call out to MLlib and train models. We're working on a Spark executor and also a streaming executor, so you can sort of push record-wise through the KNIME workflow, and that, of course, lends itself very naturally to deploying that to Hadoop as well. Why Volkswagen Käfer, you ask? Because it's a beautiful platform. If you think about it, Volkswagen Käfer is pretty much the only car where you can take off the body and the car still drives. Right? You can't do that with your Ford, whatever that you out there, they will collapse. Right? And that's one of the reasons why a lot of these fake old-timers or whatever strange cars that are driving around are based on the old Volkswagen Beetle platform. It's a beautiful platform, gives you tons of freedom, tons of choice what to do with your car. And I mean, just sort of a side note, we can talk about that over beer. I think there were other open platforms out there. I'm not sure IBM did that intentionally in Microsoft, but the way that platform was designed, and also Microsoft never really harassing students for copying DOS and Windows later, made it effectively open. So people could mix and match the programs on top of that platform. And I think KNIME is pretty much going the same way for data. And of course, also not to forget Linux in that mix. Okay, so try it for yourself. Go to KNIME.com, download it. You don't have to register, but if you register, you get maybe 3-4 mails a year, update, release, thingies, announcement. The Learning Hub is a fantastic place to get started. Points you to all of the white papers, download information. There's KNIME Press for books, and if you're interested in the KNIME Beginner's Luck, a book written by Rosaria, who Torsten knows, use the Hive 15 as code and you get it for free. Thank you very much.
I just wanted clarification on the NoSQL you were talking about. It's there right now, or is it going to be there in the future?
That will be there in the future. It's going to come out in July with the 2.12 release. We already have the node. If you really want to have it, we'll send you a preview.
Okay.
But the node exists, but it's going to come with the next release.
Okay, and the JSON to XML and JSON.
The JSON stuff is there.
It's already there.
That's already there. Yes.
Okay. All right.
One of the tricks in using KNIME is understanding what to connect what to what. And that has to do with data types. What's the best way for somebody who's getting started to get up to speed on what kinds of connections between boxes are legal and which ones aren't? Is there a crib sheet or something for that?
You're right about that. Not every node wants to talk to every node. But I don't think it's as big as a problem as you think it might be. In many cases, it's just about numbers, and some nodes, for instance, if you want to train a decision tree, it will want some sort of a nominal column. So if you only feed it a numerical data, the node will complain and say, I can't be configured because there's not a single nominal column in there. So but you can still draw the connection. The node will just be unhappy about it, but it will tell you why it's unhappy. Right?
Is there a way to peek at the code underneath to see what the type is for data that's coming in and going out of the node?
Well, you can obviously look into the code, but the nodes tell you what they expect. The documentation will tell you. You can mouse over the ports, and they will tell you what kind of information they want as incoming information and what they will produce outgoing.
Okay. And on a related topic, you've got hundreds of different types of boxes that do different operations. What's the fastest way to come up to speed on? How do you learn that? Because like learning a pictographic language in some sense, right? If you learn C, there's just a few basic statements, and once you've got that, you can start putting higher order structures. But here you start out with hundreds and hundreds of basic building blocks, all of which are really powerful,
That's a very good point, and that's of course that's both a curse and a blessing that we have so many nodes. Yes, you have tons of flexibility, but picking the right one. We have a fairly good fuzzy search. So if you're looking for something that filters columns, right, you just punch in filter, and it will show you the nodes that match that pattern. So that's one way of quickly sort of narrowing it down to maybe 10 different nodes and picking the right one. I'm not saying we are perfect on that one, but honestly, when we see people getting started with it, so after the first little hurdle, they get the feeling for what they need to look for, and then they find it fairly easily.
Okay, now one third question. What's the best way, I find when approaching a complex system like this, it's helpful to have some understanding of the underlying architecture. For example, what's its execution model and its scheduling model and its memory management model? Is there something you can point us to that gives us a better understanding of kind of what's happening under the hood, so we can kind of picture how the execution is occurring? I mean, clearly you can do a machine learning model that just has a few thousand data points, and you can do one that has a trillion data points. If you don't have the sensitivity to what's happening under the hood, it's easy to throw a problem out of where instead of getting a couple minute execution time, you end up getting a couple century execution.
Okay, a development talk would be a different topic. There's on the website under the developer category, there's actually a walkthrough example that shows you step by step how to develop a node. And I think that's a very good starting point to get a feeling for how that infrastructure works. Honestly, if you really wanted to dive deeper into how the memory management works and how you can deal with trillions, well, maybe not trillions, but many millions of rows, then looking at some of the code that's in there, for instance, the clustering algorithm is probably a good way to learn how that works. Or just post a question in the forum, you'll get an answer very quickly. We're too geeky not to answer these questions.
Just wondering if you could say something about security concerns, maybe. Is there any way to encrypt the data that's being cached? Any way to read encrypted data or hash it, anything like that?
In between, that's a good question, actually. So everything that sort of gets stored with the workflow in terms of data is something that's not encrypted. With a bit of criminal energy, as they put it, right, you can always sort of go and find out what the data is about. We have connections, of course. When you access the database, you need the credentials to get there, and they're encrypted in such a way that you can't reread the password and stuff. But we don't have encrypted ways of flowing data through KNIME. No. And actually, that's not even farmers have asked for that. They are usually very paranoid about their data.
You can always encrypt the contract.
Yeah, sure. I mean, sort of, you can encrypt the entire stuff that you have. Yeah. And actually, Dominic is working on speech recognition for KNIME. In case you wanted to ask that too.
I imagine that the overhead in terms of performance is really minimal, right? Do you have any numbers on that?
I wouldn't say minimum. There's overhead because it's a fairly generic framework. You pay a price for that, obviously.
Right.
But we have never met anybody who complained about KNIME being slower than his other tool, right? I mean, you can obviously always write C code, and that's going to be faster. But in the end, this is fairly performant, yes. So performance is not an issue.
You mentioned that database connector, you can push down certain things into your workflow, part of the workflow in the database. On your roadmap, how is this KNIME workflows can execute on Hadoop entirely, and take the advantage of cluster computing?
Entirely on Hadoop,
Yeah.
the execution. I mean, right now you can do everything that can be translated to SQL. Once you can reach out to MLlib, you can do that as well. It depends what you want to do, right? I mean, if the workflow is ETL-ish and training a model that can be trained on MLlib using MLlib routines, then soon you can do that all in Hadoop. Once you want to do something else, you're of course out of luck. What we see is the ability to be able to say, okay, this part runs on Hadoop, but in the end I still want to call out to some bleeding edge weird algorithm that only exists in R. You can combine that in one workflow. That's the true power of it, that you can sort of balance where you want to execute it and what you want to do. You can combine that. And in a true Hadoop only system, that's what you get. You get what does exist currently in terms of algorithms on Hadoop, and that's actually not that many, right? At least the ones that are honest, and they claim that they implemented it in a distributed way.
So, I recall from quite a long time ago, seeing visual systems done by IBM, and they had visualizations of the workflows. And if you ask them questions about whether they're debuggable, basically they start collapsing after about 25 nodes. It didn't scale that well. So I'm just wondering, in terms of your scale, how these workflows, how much can they scale, and I guess the term might be closed under composition. Can you compose workflows out of workflows to make very large ones?
Yeah.
Or is that sort of an ongoing area, maybe future interest?
No, we have seen people nesting meta nodes up to like 12 layers. And honestly, early on in 2007 or so, when we had was release 1.1, somebody came back and said, this is really slowing down. And we looked into it and we realized we had a little exponential problem when nesting workflows. That was literally a bug. But since then, we have seen thousands of nodes and workflows. That's not a problem. KNIME doesn't really care about that much, right? And then parallel branches are being executed in parallel, so that's not really a big deal. What you can do is, when you have the server infrastructure, you can modularize this a bit and have workflows via the web service nodes call out to workflows residing on the server. So you can modularize it a bit better, but you don't do that for performance reasons, you do that for organizational reasons, so it's easier to understand what you're doing. Honestly, 7 layers of meta nodes gets very confusing when you start diving into that one.